1 and 8.
What? What are you saying? I'm gonna talk about mine. I'll just one example. Are 5 and 4. Yeah.
Yeah, show one side.
I know I'm in your way. I apologize. You just want to list two that don't have a relationship.
Remember that those are like two separate things. So like 1, 2, 3, 4, 5, 6, 7, 8 is all in like one area. 9, 10, 11, 12, 13. You could do like 1, 2, 3, 4, 9, 10, 11, 12 as one day, but 1, 2, 3, 4 was necessary for our society. So 4 and 13 have to be.
I know you guys can't read.
You could write down
I got. Yeah, I think 4 and 13.
well, 4 and 6 are both interior. The locks and the right next to each other are on the opposite side. You could say 3 and 5.
I think it's 1 and 8.
They do
Yes.
What's on the interior of our so what's on the interior of mine on
yeah, that's the interior. So you could do 3, 5, or both are considered consecutive.
Are those
why would it be
like 4 and 6 on
3, 4 would be they're on the opposite sides of the
or
barrel.
it might be 3 and 5.
Yeah, they're not
1, 2, 3, 4, 5, 6.
okay.
Well, there's multiple, like, there's also the
Yeah, would you
horizontal.
consider 3 and 4 consecutive interior or just?
Oh, boy. There's
3 and 4?
Yeah. No, because it's like a line.
So consecutive same side.
Yeah. So because there's line, it wouldn't consider consecutive interior.
Well, they're not interior if you look at it that way.
4, 11, 13. 11
So it's
3 and 4 would be linear, yeah, but they're not interior. These are interior and these are interior.
See, I told you.
Oh, yeah.
Alright, do we need like a minute or are we pretty much clear enough?
We're done.
Okay, so from each group, I'm gonna ask. How many groups do you have? 1, 2, 3, 4.
You said 4 and 13.
So, corresponding angles. Vea, somebody from your group. Can you guys give me a pair of
You have to
corresponding
be on the
angles?
same line as
There's one.
inside 4 and 8.
4 and 8. Do we agree that those are corresponding?
Yeah.
Yeah. Caleb, from your group, alternate interior angles.
11 and 14.
11 and
You
14.
said
Are those
five.
alternate interior?
You said a 5 and 8.
Michael, from your group. Wait. Do we
Yeah.
agree? Alternate
I
interior?
agree.
Okay, Michael, from your group, alternate exterior.
1 and 8.
1 and 8. Do we agree with that?
Yeah.
Yes. Abby, from your group, consecutive interior.
3 and 5.
3 and 5. Do we agree?
Yeah.
Yup. And then Bella, from your group, give me someone no relationship.
8 and 14.
8 and 14.
Yes.
Do we agree? Yeah. I know you guys are all like, why are we doing this stuff from chapter 4 or chapter 3? We're just slowly gonna start touching up on old stuff to start EOC reviewing. So as we start doing our launches at the beginning, well, as we continue doing our launches, they're gonna be more EOC review rather than related to what we're doing. Because this was one that everybody did pretty okay with, but we're just gonna go back and touch on more stuff. So, for today, our learning target is identifying lines and segments that intersect circles and using them to solve problems. Remember yesterday, we did arc angles and inscribed angles. We used the inscribed angles to find the arcs. We need to know how to do this because once we move past our arcs and our angles, we're gonna move into circumference and area and all of the things in circles that we need to know how to do. So this is our baseline. We're gonna start inscribe polygons tomorrow. So this is kind of our stepping stone. So you learned majority of the material yesterday. Today we're gonna do like a quick review, and then we're gonna transition and we're gonna do our lovely scavenger hunt stations. Sound good? Okay. So moving into our quick review. We all know tangent lines. What does it mean to be tangent?
Touching one point in a circle.
Touching one point in a circle? On the perimeter of the circle. What is that thing that they have to be?
90 degrees.
Perpendicular 90 degrees. So a perpendicular tangent is a tangent to the circle, is perpendicular at the radius of plane of contact. So the radius has to come down and be perpendicular to the line to be tangent. Remember we did all those problems where we had a line here and I had to ask you to find the radius? The one with r squared that we all hated? Yeah. So we all know tangency. This is the first thing that we talked about. We all know how to find our right triangles and do all the things with tangents, right? Today we have a couple of tangent problems. I apologize. There is, I think, one where you have to do the r squared stuff. And there are 2 challenge problems. So good luck with those, but I have confidence in you guys. So now for 2 tangent lines. This is where we talk about 2 tangents that come out and diverge into one point. What is the key thing about these 2 tangent lines? They're congruent. So they both have their point of tangency where they're perpendicular, and then they come out to the same point. So that means from here to here and here to here, they're congruent. So if you were to have an expression here and an expression here, what would you do with them to solve for x? Set them equal to each other. So, do you have any questions about tangents? Do you remember everything with them? Yeah. If you guys are going to do the x squared problem and you get a little stuck, I will assist. I know those are a little tougher. Sometimes you just need reminded of our steps. So then minor. Okay, let me come back here. We're gonna restart. Major and minor arcs. Okay, I did that in class yesterday too. I can't think of it all. So major and minor arcs are arcs of a circle. Our major arc is made up of how many letters? 3. Our minor is how many letters? 2. Beautiful. What about a semicircle? 180 degrees. We haven't talked about naming semicircles, but naming semicircles is something we're going to do later on anyways. So right now we just need to focus on our major and our minor arcs. So we know everything about them. How do we find our arc measures? What do we use inside the circle? So we use our radius and our diameters. We use our inscribed angles, remember? So if this angle right here is 73 degrees, what's this arc? 73 degrees. That was really hard, wasn't it? So, this is all the stuff we did yesterday and that you guys did the practice work on in your packets. So, now, today, all we're going to do is reinforce the skills that we already built yesterday and then kind of extend on them slightly. So, everything we did in class yesterday was like the easy problems. Today, they got slightly harder, a little more rigor, and then there's a couple challenge problems. If you get on a challenge problem and you are like, I don't even know where to start, talk to your group. Maybe consult somebody from a different group if you guys can figure it out, and then I will give you some pointers. But I don't think they're so hard that you guys won't be able to figure them out. So leave your whiteboards on your table. Within your group, you guys are going to, when I say, everybody's going to get up and you're going to find a station. There are 12 stations total. You have your tracking paper. The little square in the corner is where you write down your letter. Like you guys can see this one right here, it says 9-T. So you're going to go to number 9, solve the problem, and then you're going to fill in the letter T. And then you're going to move on. There's nothing in these that like leads you to the next problem, because I know it sometimes we get all confused. So we're just going to bounce around from blank to blank, and once you finish all 12, you can have C. And that's when you can pull your packet back out and finish the rest of that stuff. Everybody all cool? So within your group of 4, find a station. Remember, some of them are a little hidden. Yes, we're here.
defining Pythagorean theorem, right? Yeah. Yeah, so that would be 48.
Don't forget your calculators if you need them.
Or this one. I think this one would be the hypotenuse. So I'm trying to find
So 24 squared plus 48.
what is this? 21, 22. 48, yeah.
I like that you drew it.
It's pretty bad.
It's like a bird. Yeah, but now if you go to study, you have that to reference.
This is how this one.
Instead of just work with the picture.
So
You wanna work on 19?
It's
It's like new. It's your calculator now. You know, I did all of these and I figured that one for some reason was gonna be a 4. Because you guys are gonna all be looking at.
2 plus 2x
Where you get it?
We know that AB has a diameter.
Yeah, my 3.
And we're trying to solve for x. So we know that.
okay, so what are you doing?
This one you need to do that.
This is the hypotenuse.
That's the hypo. Oh.
Yeah, but that's not the first one. You gotta
I'll look at my eraser.
No, I thought that was
22, 19,
Like the atom?
Yeah, yeah, because you would have to make sure, right?
Yeah, you're on square for this one. Yeah, but make sure you're paying attention. Are they asking you to find radius or are they asking you to find the side?
No, I think 11.
Oh, never mind.
Oh, okay.
Oh, let's do that one behind the. Oh, right.
Because at the end, you're gonna solve the riddle that's on the back.
Same way.
Now we gotta work by our groups. You can work together if you get stuck. There's 12 of them. They can bounce around to a different order.
Oh, which one find it?
Okay.
Oh, so you
Then find value. This is gonna be a little.
A little more interesting.
So we have 21. So we're trying to select 21 do this, we do
Alright, what's our thought process with this one?
plus 9
What was our first step?
x
B,
squared.
C, T, so we have to
Plus
find
9 squared, which is 81, plus 9 plus 18
So I did,
You just one section.
x squared.
I did 180 minus,
We're basically using the Pythagorean theorem to solve for what x.
How do you know it's
Since we know this is the right angle, we know that this is the hypotenuse.
They'd be vertical angles, but they'd be vertical, but we're not doing vertical angles.
Then
We
this
need
is
to
the right
prove
angle.
that it's also
We can
74.
just do
So
Pythagorean theorem to do x squared.
how can we prove that it's 74? Do we have certain parts of our circle that we can use to prove it?
X squared, x plus 9 is 24. And then you can just distribute the square to get x plus 9 is 9.
What's that line called though? That goes diameter. So that's what I wanted you guys to see. We have a diameter here and we have a diameter here. So this half is 180, so you can figure out this piece. And then this half is 180. So you may solve this and find that it's not 74. It could be 73, it could be 75. It could look really similar and just be slightly off. So make sure you're proving it first. It is 74, but I want to make sure you guys prove it. Because I don't want you to assume that on a test and then be slightly off.
so do 180 plus 7.
So do you remember how to do the perimeter ones? Beautiful.
Oh, we can do this one and that one.
Yeah, that's
Okay. Okay, 12.
WX is changed to circle Y, find WX. So we're finding this side. So we're finding the tangent side. So this is 25, this is 23, because it's the rate of the eye or whatever. So the whole thing is 48. Well, I think we could just use Pythagorean theorem again.
Yeah.
Because it's just b squared. The whole point is that you have to remember that so far it's the radii. So it's going to be b squared. 23 squared is 529. So find c. And then 48 squared is 2,304.
Plus.
What's it? Subtract it. Now. So 1775.
And also immediately notice is there a square on both sides. You can find
42.1.
so you get 21 squared.
No, we add this. And then the letter is N. Okay, now that one. Number 2.
81 plus 18x. And then you just solve.
So what is the measure of WYZ? What's 7 plus 2? So WYZ. Major 129. I think ZY is 51 too. It is. Yeah, so 51 minus 180. It's 129.
If somebody's
Alright, can I steal everybody's attention? I'm sorry, I did not mean to scare you. I have a quick question. Okay, let's groove. Everybody, I have a fun question. If I give you guys an arc that is 179 degrees, what is it?
Minor.
Minor. What if it's 181?
Major.
Major. What if it's 180?
Semicircle.
I thought I was gonna get you guys. Okay, never mind. Go back to what you're doing.
What are we doing? Measure of Y, W. So it's so it goes yeah. So 51 plus 129 plus 151 again.
Okay, let's
So
work on
measure
11.
of WYZ 51 times 2 plus 129.
So trying to solve for PST. So as you said, immediately you can tell that it's going to be a
You guys found my
bigger
most
than
hidden
180
one.
because
I'm just kidding. This isn't my most hidden one.
it's greater than.
No, you're very close to my actual.
PST is going to be everything but this.
Oh, it's right there.
So
We already did that one.
Oh, you're. Okay, never mind.
Oh.
I didn't want to hide them
another
too
one.
hard because I was gonna put one behind the computer or the phone thingy, but I wanted you guys to be able to find something.
okay, and we know that QT
Okay, are we getting
is
stuck on
probably
anything, or
going
is
to
this
be
all like pretty
a
general review?
line, so we can just do 180
That was
minus
the point,
74.
because now the next thing is gonna be a little more.
180 minus 74 is 1. Because 180.
was it?
Technically,
Yeah. There's another one. I
what I was
honestly, I
thinking
don't
of
remember where I
doing
put
was I
it.
was thinking of
This
doing.
week.
Is this a challenge?
Yes.
is this considered a diameter?
Yes.
This?
Yep.
Okay.
There's 2 diameters on there.
Yeah, I know. This too, but it kind of looks janky. I don't know.
wait, no. 21 squared.
That's just the way that the picture is created, but you're right. It's a diameter.
Yeah. Okay, so you can do 180 minus 74 to get 106.
And we know that.
And then we know that we're just trying to solve for PST, which is everything but this. So we just do 360, the whole circle, minus 106 to get what?
Equals
PST.
25 plus 23 squared.
Does that make sense?
Plus 21.
Just 48.
Minus 106 is 254. So PST,
It's okay. That's wrong, but it's okay.
our PST equals 254 degrees.
We put 74.
I'm gonna go.
Let's just get out. Forgot the T. I greet you the moment your squirrels they stretch your days arrows.
I had 42.1.
I bring rest and adventure before classroom when I'm
Make sure you're writing down your letters. You have your riddle to solve on the back. And there may be a small reward with the first people that solve the riddle. Isn't that so exciting?
There's one right here.
Yeah, how about we work on both? You can work on both at the same time.
Why would she put that there? It says rush. I'm not gonna try to go for the reward.
That's also 15.
Are you guys all ready?
That would be, yeah.
Okay, with this one, you're trying to solve for WYZ. Immediately we can tell it's a major arc, so it's going to be bigger than 180. WYZ is everything but this, so we're just trying to solve for this.
Wouldn't it just be 51? I mean, I know we're not
That was
supposed to like
fast. That was good job,
assume
No, it's not.
narrow, I mean,
You mean
verticals, but it's 51.
But we should do where we know this is the diameter. So we just do 51, 180 minus 51 to get what this is.
Yeah.
So once you do 180 minus 51, you get 129, right? And then we know that WYZ,
So would it this be 29 right there?
this would be 129.
Yeah, that.
Because this is equal to 180. This whole thing, you're just subtracting 51.
So
So,
when you do 360
W-
minus 129.
Exactly. WYZ is everything but this part. So when you do 360 minus 129, you get 231. Which means that WYZ, our force WYZ, equals
We're kind of like preparing ourselves for the next thing.
This is not a word. This word does not exist.
Are we working on the one on the desk or the
You want to do work on this one?
Yeah.
Is this going to be another one? Oh, this one's
I love when you guys try the make my heart happy.
This one, 12N.
We haven't done that one.
Remember that whenever you have the radius, yeah, we're working on 12N. Whenever you have a radius, all radiuses are going to be equal to each other. So since we know that this is equal to 23, we also know that this is equal to 23. Does that make sense?
Yeah.
Okay. So you can do, since we know this is going to be the right angle, we have a triangle that kind of looks like this. We have 23, we have 25 plus 23, which is equal to 48. And then we have x, so we're trying to solve for.
So wouldn't it be 23 squared plus b squared equals 48 squared?
Exactly. So you can do 48 squared minus 23 squared to equal 1775. Then you square root that. Square root of 1775 would equal this jargle of a number.
Are these the same?
Can you prove they're the same?
Usually they give us a lot of it's equal to 5
What lines
square
are you
root
using?
71.
I'm gonna make sure
What are those
that
called?
that's the answer.
Diameters. So on each half of your diameter, it's 180. So you could use your
Exactly.
two separate diameters to prove it's 74. I'm not saying it is. I'm not saying it isn't. I'm just saying you need to do the math.
04 minus 529, right? Equal that 1775.
This is
5 for
all this.
that's what x equals to. Or we could kind of round it to 41, 42.1.
Minus 180.
42.1 or what?
Or
Radical
Good
5,
job.
71.
5 radical 71.
How did you get that so quick?
My calculator.
Oh.
How do we do
Both
that?
those are equal to W. Make sense?
How do you solve?
Let's move on to 8. Oh, are you confused? Let's move on to 8N right here. 8N, we're just trying to find the perimeter. For perimeter of DEF.
What are we working on?
There's gotta be a better way to do this, right? Oh, we can do they're equal to each other. So we know that this is equal to 15. And so whenever we have one of these triangles, you know that this is equal to this part of the triangle. So if we have 7 here, we know that this part is equal to 7. Same for this. When you have 15 here, you know that this part is equal to 15. So to solve for this side, we can do 19, the total of this side, minus 7. Does that make sense? Because you're taking away this part of it to get 12. Now we know that this part of the side is equal to 12. We know that because of whatever the shape is, that this is going to be equal to triangle, circle inside of a triangle.
So remember your lines of tangency.
Yeah. So we know that this, I guess I never thought of it this way. I just
Making connections. You have 3
this
sets
is
of
just a line
tangents.
of tangents. So we know that this is equal to 12 because that part's equal to 12. So we can do 12 plus 15 to get 27.
Can I offer?
27 is equal to this side.
Can I offer a visual? If I take my hand and I cover up all of this, those are 2 lines of tangency, right?
So it would be
Yep. But just think of it, you have 3 sets of those. So you just have to do some math to figure out what that is. Because you know it's going to be 7, so it'll give you the other.
And that's how you get that this is a 12 because
They're not marked as lines of tangency, but that's exactly what they are.
and then to solve for the perimeter, you just do
So this is
15, 15 plus 7 plus
You
27.
have 3
plus
letters. Are you a
19
minor or major?
equal to
Major. So
68
are you above how many degrees?
equal to P
You have how
of
many diagonals
triangle
on there?
DE.
True. How many do you got?
Perimeter of DE.
2. Make sure you and a radius. Perfect. Make sure you use your diameters to prove your.
Anybody confused?
Move on to the next one. Still writing?
yeah.
What problem is this not being? Let's try 10 I. Okay? Ready? I'll just try it.
Alright, can I interject? Well, how did it know where you were? If you are over halfway done, raise your hand. Okay.
We're on the last question.
Okay, awesome. So we have about, my timer went away, but we have about 3-ish minutes left. After you guys finish all 12, you have your 12 letters on the back. You gotta unscribble them to solve your riddle. Read your riddle a couple of times. All your letters are there. So keep doing, keep finishing.
is 50.
So I think
This is
We know.
those 2 describing. So 61, 51, and then 51. Cross it out. So minus 51.
Yeah, that would be 74. Then this is 106, so then you subtract everything. 36.
It's permanent. So you do 15 times 2 equals 7 times 2. Or, never mind, I did that wrong.
36 minus
15, 12, 12, 7, 7.
Now can we see? So when you do 24 squared plus 7.
Or you another one on the desk?
Oh, I didn't even see that there.
See, I figured that would be the one that you guys would find because it's the only one not on the wall. Well, and the computer part.
Yeah. We're working on this problem. And it's like 24 squared plus 17 squared.
Oh, this is 2.
Is there a simple way to get this other than 24 plus 17?
So what's the missing
KJ?
Yeah,
Is equal to x plus 17.
you did type that here?
No, we know that this is 17. So x plus 17.
But what if we just did Pythagorean theorem with 24 and 17 by KJ?
Yeah, but then we wouldn't know because
A squared plus B squared plus C squared.
But if we find C squared and we have that, let's just say KJ is 27. And we know the radius is 17, can I just take 27 minus 17?
so you can do like 24 squared plus 17 squared. They get 865. This is
There's really no word.
and then just do minus.
Here, let me reread the.
That's why when you go from the organic square to one that you don't, it gets confusing. So you need to just back up and see what we're actually being asked to do.
So 40 is So it's C. It is, right? Yeah, same as right here.
So that's probably all 129. So then,
We're done? Yay. So, you guys are sits.
oh, it's the measure of all of this?
Oh, you guys are first line.
What did you get?
I knew it. So you guys can have a seat at the desk we're sitting in now, and then work on your packet, and then we're going to do
Five, 7, 8, 10, and 12.
You don't, yeah, as long as you that makes sense. Thank you, Bella. Do we remember how to do perimeter?
That's 23.
Can I provide a visual that might be helpful? If I take my hand and I cover up this, is that not just two tangent lines? Yeah. So they're equal? So 31. Yeah, is that two tangent lines?
Okay, so
And then that's two tangent lines. So you just need to use these. Beautiful. So if we're done, can we go back right now? Yeah, if you're done, go back to your seats, work on the riddle, and then you can pull out your packets and work on that.
Are there any points?
and then that's the